All right. Hello, everybody, and welcome to our latest version of the Neo4j Online Meetup. So I'll give you all a few seconds for the people to get in who are rocking up on the hour. We'll get started in, let's say, a minute or so. All right, it's a bit of a short minute, but I reckon that'll do us. So we're ready to go. So welcome to the online meetup. If you haven't attended one of these before, we have a little bit of housekeeping. So if you have any questions, feel free to ask them when you have them on the YouTube live chat on the right-hand side of the video, and I will collect the questions and ask them to Marco and Alberto when we get a bit when they give me a gap to get the questions in. If you're not able to see the text on any of the slides or when they're showing a demo, you might want to change your resolution. So in the bottom right-hand corner, there's a little kind of settings button with a HD icon on it, and you want to set your quality to 720p. And if you put it at that, then you'll be able to see everything clearly. Other than that, I guess I'll just do a quick introduction of myself. So my name's Mark Needham, and I work here in London on the Neo Dev Relations team. And our talk today is going to be on versioning your graph. And this is a tool I came across while searching Neo4j tagged repositories on GitHub. And I spotted this one, and I pinged Marco about it. And so I might as well let introduce our guests, I guess, at this point. So we've got Marco and Alberto. So I'll let you introduce yourselves and maybe tell everyone how you got into Neo4j, what you do, etc.
Okay, so hello everybody, thanks for joining. And as Mark said, today we're going to talking about versioning graphs, and we started working on graphs like 2 years ago.
Yes.
On the previous company, because we used to be colleagues, and we started getting into graphs. And then we started feeling that graphs are going to change the way of thinking a DB. So after some brief projects on it on the previous company, like local things, we started developing with our company the JDBC connector. So actually, we are contributors of the Neo4j JDBC connector, and you can find it online on the JDBC of Neo4j contrib. So after that, now we changed to the company we work for, but our passion for graphs didn't change.
No,
so
that's good to hear.
Yeah.
Didn't put you up.
Great. And then one day Marco came to me saying, okay, I've got this idea. Let's see what we can do on it. I say, okay, let's try on our spare time to develop something. And it was about graph versioning, so the topics we were going to talk about. And actually, we found out it really exploding bottom of our ends, because it was just a simple challenge to do, but now it started growing, and look where we are now. So what to say?
We can switch to the presentation.
Yeah,
so
some slides.
We can have some slides so people can also read something.
Yeah.
When
did you do an intro for you as well, Marco?
Yes, I've got an intro.
Okay, so you
came up.
Cool.
Soon.
It was just a global intro of us.
Yes.
All right. Okay. Yeah. So just to give a quick introduction from me for the topic. So this is so versioning graphs is like a very like frequently asked thing that people are always asking. They have a domain where they want to version the data, and they don't really know the best way to do it. And so I guess hopefully you guys will be able to teach us at least the way that you've come across that works best. So I'll hand over to you now, and if you any questions, ask them away, and I will ask them as we get there. Cool. So back to you again, Marco and Alberto.
Okay. So Neo4j Versioner Core is the name we decided to give to this project. Of course, it's versioning, so even some friends of mine say it's not cool as a name, but that's effective. Yeah, gives the idea. So, okay, today who we are and why are we here probably is already explained. Now we have some detailed presentations of us, but still, you know it. And what is Neo4j Versioner Core? Of course, we're going to talk it, and you see how we developed it and how it works. This is our idea. So probably there are others, but we really believe in this. How can you use it? Of course, because it's usable inside even also inside your projects. So I think it's interesting to see how to embed it in your applications. And then what's next? Of course, the future milestones and so on. So first things first. Okay, should be my presentation, right?
Of course,
yes, mine. Okay, I'm a software developer at Gruppo PAM, which is an Italian retail company. As I already said, I'm a Neo4j contributor. Rubik's Cube addicted. Yeah, actually, I tried solving Rubik's Cube with graphs, which is another interesting topic, but not involving versioning. So today we'll not be talking about it. And IoT apprentice. Okay, now it's a new passion that started for me. I think I said enough.
Okay. So hello everyone. Thank you for joining us with this online meetup. And my name is Marco Falcer. I'm a software engineer at Pixel Printing, which is an upload and print company based in Italy, near Venice. We are a leader with this kind of business. I'm a Neo4j certified professional. Of course, with Alberto, I'm a Neo4j contributor since we started the Neo4j JDBC driver for the new Bolt protocol. Okay, and of course, I'm a graph addicted. After I discovered the Neo4j, almost everything that I see in real life is a graph. And I'm also starting seeing that everything can be modeled with the entity and state. But I think we will talk more about this topic in a few minutes.
So, what is Neo4j Versioner Core? Of course.
Okay, Neo4j Versioner Core is our module that we created as a set of 13 procedures, of course, Neo4j procedures. And if you want to say it in a short way, is an entity state of the box manager. So, of course, our first aim was to give a tool to people to handle this kind of model that we came up, just mixing a couple of models that we just found while we were browsing how to resolve this problem. We started with the model, and we thought, okay, just let's start with an easy topic that is one of the use cases we will talk about later. And it was the cart example, of course, on an e-commerce. And we came up, okay, let's think that a company which owns an online store want to track their users and their behavior while collecting things on the cart. Maybe also how they behave, I mean, adding items, removing items, changing the quantity, applying a discount, for example. And we came out with this naive model. Of course, we've got a cart, and we got an item that has been added to the cart. And we thought, okay, now we need to add one more item and also store the history of what the user is doing. So we created another cart which owns both the item that has been added to the cart. So basically, if I'm navigating through carts, I can have the whole history about that cart, which of course is connected to a user, but we're just simplifying the model, so it's a little more little for this example. And of course, if you want to remove another item or adding another one, we will come up with another cart with its item. Of course, this one led us to think that we're creating too much duplication. And then we thought, okay, maybe we're just over-engineering this model. We can do something better and maybe more effective using just a normal relational database. And then we came up, yes?
Quick question. So did you create like a new car structure every time you changed any item? Or
yes, because it's the entity and its item, because we wanted to create a history for the users. So.
Yes. So if you were like an annoying Amazon user like me, where you like buy something, take it out, put it back in again.
Also like me, because I'm always adding, removing,
Yeah.
maybe because there are more retailers with the lowest price and so on. So yes,
Yeah.
I basically emulated myself doing this example. Yes, of course. And we switched to tables, and of course it's a really simple example. We have the shopping cart with some columns and an ID. And we also have a shopping cart state. So we switched between the items to a particular state, because, of course, the state is something like a snapshot of the current cart. So our model changed with something more complex, or maybe more easy to understand. So we have many states for one single shopping cart. For example, the first 3 rows in the shopping cart state. And then we thought, okay, we will have a huge table, which is the shopping cart state one. And wait a minute, we're also having relationship between those rows, because if I want to store a sequential switch between states, this is a bad example about using relational database, because it came in mind that is really similar to the friend of friend example that we basically
you're joining the shopping cart state to itself.
Yes, of course, because I needed to have the whole stock, the whole history and the whole sequence. So this is the worst case that we can end up using a relational database. The first thing we usually learn in the basic Neo4j course, for example. So we came up with the last one for the moment,
of course.
because maybe it can change in the future, which is this one. So we came up with more relationships, and of course this is a better way maybe of using Neo4j, since relationship are first-class citizens, and we will have 3 different relationships that we will analyze a few slides later. And if, as you can see, there is no more duplication. We will have an entity node, which is the card, and many states that are to get connected together. And we'll also store the sequential, how they came up in time. So if we want to go more in details, we can see how the data model has been made. Of course, we have 2 kinds of nodes. We have entity nodes, which are user created, and they got a custom label, for example, the card, or maybe a device if you are in the IoT example. And state nodes. State nodes are auto-created from our tool, from Versioner Core. They can have additional custom labels. Of course, they can have properties which they can change between states, and so on. And currently, we have also 4 relationships, which is the current one, which indicates which is the current state of the entity. The has state, which means that a state is, of course, something related with our entity. The previous relationship, which came between states, and this can help us to have the whole sequence of states, and the rollback. And for this one, I'll show it later with the use case, because this will help us to don't make loops while we want to roll back nodes. Because of course, if I want to roll back to a different state, we have a procedure for that. So basically, this is an example of how our data model is. We have the device, which is the entity, and the whole different relationships, and those nodes for example, the state node, the error, another state, and an alternative state, which are all state nodes with different labels. As you can see, previous relationship can help us to start from the current one and go back in time. Not literally back in time, but at least for this model. As you can see, there is a rollback relationship. This works like this. If I want to roll back from example, from this state the alternative state to another one, and for example, I want to roll back the current state, this relationship can help me to not to come up in a loop between those two states. Because if I'm constantly roll back the current state, I will end up with okay, the next node will be the state node, and the next node will be another alternative state node, and so on. So this just go like in a recursive way back to oldest node and prevent this unpleasant situation. So for example, let's see how adding a state to our model currently works. We can start with this. Okay, we have a device which has a current state, and this is an example when we just initialize our entity with a state. Next, when we want to add another state, the current relationship is removed, another state is added to our device. Next, the current state is added to this new state, and at least the previous relationship is created between states. So the first useful things is, okay, we're managing those relationships just with one procedure. And this is our our first main goal with this tool. And then we just came up with the other procedure.
Yeah, if you can go back for a moment, I want to state out that has-state relationships also has been introduced because of performance. Because
yes.
If you're looking for a specific state at a certain time, you can search it just looking for a has-state relationship between that period you're looking for, and you will find all the states in that period. So you can quickly retrieve the states, even like 2 years ago states, with such relationship. Otherwise, you would have to navigate all the previous queue, and it's going to take really a lot.
Yes, but this also is better if you want to retrieve the whole list. We will use the previous relationship as well. So those two models are well working together. We were thinking, do we need to choose one or another one? We just say, okay, relationship are first citizen, so we choose both. And of course, this also helped us with some performance that we made in our early development. Okay, so if you want to give a short explanation of how those relationships are made, we can see that relationships are also storing datetime as a time in millis. For example, the current relationship, of course, stores the current time. I mean, the exact time that has been passed to the procedure or that has been logged due to have the current state. The has state can store two kinds of date. The end date, which make you understand that it is an old state, because current state and with the current state will have both current and the has state with the start date, which is the same date as well. The previous relationship will also store the date that we are using, and of course rollback doesn't need that because it's just useful for our framework to work better with this kind of situation. So we grouped our procedure in 4 groups, which are of course topic related. We can have 3 procedure for creating or updating your model, our graph. Of course, the init procedure can help you to create the first entity node with its first state. The update will add another state to the model. The patch one will update the current state with the properties that we're passing to it. And of course, we also have a rollback group. For example, if you want just to simple rollback to the previous node, we just use the rollback. Or if we have a specific state that we want to roll back to, we use the rollback to. They are really easy to use. Of course, we have a few procedures if you want to retrieve some data, and we will see them in some minutes. Of course, we can retrieve a current path, which will return us a full path with all the state of a specific entity. The current state will return just the state, all the nodes, just retrieved by label, and we will see this and how this one can be useful. And of course, we can get by data. And this is what Alberto was talking about. Yeah. If you want a specific state on a specific date, you can use this one. We will also have some difference, comparison procedure, which can help us to understand what is happening between a couple of states. To specific state, previous states, and current states.
So how can you use it? Yeah, of course, you just have to use it inside your Neo4j, but you can also use it in your code, because actually it's a jar, it's a Gradle project, so you can import it. We have two examples here using Jetpack, because actually we're releasing on GitHub pages, and this is the quickest way to let you download, include it into your projects. Actually, we're at version 1.2, so it's simple as you can read. Almost anyone knows Maven and Gradle, so it's like this. Of course, I already said it's a stored procedure in Neo4j, so you just have to download the jar from the release page on GitHub and add it on the plugins inside your Neo4j, start Neo4j, it starts working. Inside your Java code, we're getting the power of Java 8, so we're using optional, and we created a builder usable from your code, requiring you to specify the database you want to interact with and the log that the procedure is going to write on. So you should use this builder passing the DB and log that are the only two classes available in the context of a store procedure. Okay, now if the init, now here we're initializing the init class, which allows you to initialize the entity state giving an entity. So here we're instantiating the init class, and if it's present, we're calling it, passing the label, the properties, the state properties. So actually, I would like to say them out. First one is the label, which is a string, and it's the label that's going to be applied to the entity node. Entity properties are the entities which are stored in the properties node itself. Which is stored in the entity node itself. So the entity node will have such properties as static properties. They're not versioned. Otherwise, there are the state properties, which are the properties stored in the first state. So this method is also instantiating the first state with the current one. Then we're adding additional label for the states. If you want to set up it already as a ready state, error state, or something like that, you can do so by specifying some additional label. And then the date. The date, of course, you can not specify it, and the code is going to take the current date, so the today. But you can specify it is a timestamp milliseconds. So by doing so, even these 6 lines of code, you're instantiating your entity state model.
So basically, if you want to create your own procedure and use our tool, you can do that just by importing it as a dependency in your project.
Yeah. Also, you can import it in other kinds of projects. You just need to give as a DB a Neo4j instance as a log, the log you're using. So that's it. Using inside Neo4j is also quite easy because it's the procedure way of the Neo4j procedure way of doing things. So as we have two examples here, updating a node and rollback a node. So first, before using the update, we need to specify which entity we're going to update. So the match the device for selecting the entity we're going to update. As you see, we're going to call it D. Then we call the procedure itself, passing D, and some variables like context, which are the properties of the state we want to insert in the new state, error, which is the label associated to the new state, and then the timestamp. Of course, we can skip the timestamp and it will take a current timestamp. The yield node, the return node, is for retrieving the node created by the procedure. So we'll see the actual result of such operation. Just by placing these lines in your Neo4j browser and selecting a correct device entity, you're updating the state. Then the rollback example is easier than the previous one. We're just rollbacking the current status on the previous one. So we just match the node as we did previously, and then pass it to the procedure rollback with a timestamp, and then return the result of the operation, and then you're done. The actual model will change according to what Marco said. Okay, so before this, we're going to talk about the first use case. We're not showcasing it, we're just talking about and explaining the many ideas behind it, because we'll have a bigger showcase on similar situation next. So
but it's a surprise.
Of course,
spoilers.
Okay, so considering a shopping cart, you should think of the shopping cart as an entity node. So it will have some static variables like session ID and so on, and it will have, of course, the state variables, which are, for example, the items connected to each variation. Like I add an item, okay, you create a new state with that item, which is previously from the different state, because the previous state doesn't have such item. Even if you remove something or change the quantity and so on, you're creating new status on the same entity. So if you want to see how the user is adding items to your cart or is removing, because sometimes it's useful to find out which items are going to be replaced. Like, okay, this user added this in the cart, but after 5 steps, 7 steps, and so on, he removed that item and added another item which is similar, so we can retrieve such informations. Okay, so adding an item means adding a new state with the item added. Increasing, decreasing item quantity, of course, creates also new states. Removing items creates new states. Checkout is like you create a new state and you add some labels, probably like checkout done or so, like so.
What the user think that is.
Yeah, of course.
The most useful
the way we thought on the shopping cart.
Yes, of course.
Okay.
Before you go, have you done? We've got a few questions for you before you go on to the next slide.
Okay.
Okay, so I'll go from the top. So there's a couple of questions from Brian. So the first one, the initial example that you showed, so this is the one right at the start before we did any entity state, was showing how different carts had different sets of relationships. So the question is, does your plugin version does it attach relationships as well, or is it only versioning properties on nodes?
Yeah, that's what we're going to talk about. because we found out that we need to also version relationships, but in the next few minutes we're going to see how to do so, and we already did so.
Brian's ahead of the game. All right, and Brian's got another question as well. So
okay, great, Brian. Thank you, Brian.
He's asking about if there's loads of changes, like say we've got Marco or me changing the card, does that mean you end up with loads of has-state relationships all connected to the same node? And does this cause any issues when you are scaling the model?
Actually, we tried performance tests with like million. Yes. 10 million of nodes connected to the same entity and trying to navigate them. It's not causing problems because, of course, if you're seeing them in the browser, it's going to cause a problem because there are too many relationships. But
oh yeah, that wouldn't be such a fun.
You should navigate the entity state model. Actually, we stated out 2 ways of navigating the entity state model, and you should use the one which more matches your needing. So if you're just checking, starting from a state which is the 10th previous one or simply the previous one, you should navigate as the previous. But otherwise, you will have the as state, and the as state is intended for searching on a big range of periods.
So basically, when we are using all the get procedure, it depends on the procedure that you are using. We are just going through different relationship. For example, we can choose the tool will choose between the has state relationship or between the previous path. So basically, that's why we ended up with both models, the has state and the previous one. So the linked list help us if we want to go through all the states, but if we want to go to a specific state, we will just pick up, the procedure will pick up the has state node. Yes.
Okay,
so
cool.
we hope that is not a problem since we tested it, but of course if all the developers that are watching us want to do their tests as well, we are really open-minded to find different solutions for any problem that will come up with our tool.
Okay, cool. I've got another couple of questions for you as well. So
great.
Next one comes from Abhishek. So the question is, if there's a change of property for a particular node, does the versioning tool create a new node?
Well, how can I say that? For example, if you want to just update a property, for example, you should create another state, so you can have the whole history of the entity.
Yeah, that's what state properties are intended for. So if there's if you have something that is going to change, you persist it in the state, and when you already change it, it creates a new state. Otherwise, you persist it in the entity, and you're changing it manually. You don't need the versioner.
Just giving you a simple example. If the entity is a person, for example, me, Marco, and I've got my initial state, the current state, which has all my information, for example, the address as a string. So if I just move to another house, a new state will occur, and that state will have the updated address. So I hope this can explain.
Whereas if you had like a piece of information that's very unlikely to change, say your date of birth, then you would just store that on the person.
Yes, that is stored on the entity, of course. Yes.
Cool.
Birthday, yeah.
All right, we've still got more questions. I've got one more.
Ooh,
so
very good.
This one is from well, the username is Varden from the USA, so I assume the person is from the USA. So it says, what happens with state that you're rolling back from? Do you keep it, do you delete it, or do you're keeping it, and then the last bit is
No. As you see in the,
we just go back. Okay, back.
This one.
Okay, this one.
Here we have the 2 purple nodes are connected with a rollback relationship. So as you can see, the newer state
is a copy of the previous one.
Exactly a copy of the previous. As we stated in the rollback code, you're not specifying new properties or like so. Sorry, you're just using here in the rollback example. You're just choosing an entity and saying rollback. So it's rollbacking. It's keeping the the previous state from the current, and setting it, copying it, but setting it as the new current state.
We will do that live, of course.
Yeah.
So the next use case, which is the printer one, which can be kind of IoT example. Of course, is a simplified model for our presentation, which lead us to have a printer entity node, which will have its information that we will see in the next slide, which is, of course, the demo. And every state node is an event handled or generated by the printer. For example, I'm ready to print something, or a job has been added to the queue, a job has been removed, I'm starting to print something, I ended printing, I came up with an error. So basically, yes, we're storing everything, and we also do a rollback, so you can actually see what's happening under the hood.
Yeah.
Okay, so we can go for a live demo if there are no more questions. Or
yeah, we're good for now. I'm sure we got thanks from Brian and Varden. So those questions are all good.
Thumbs up for them. Okay, great.
Yeah.
Glad to help.
Okay, so we just moved to our Neo4j browser, which is pretty close to Mark. Hello, Mark.
There's me.
Yes, of course. And we will help us with some, of course, we will create some queries just for just making mistakes. Okay, just tell us if you can see what's on the screen.
I'll probably zoom it in a little bit, maybe a couple of times.
Whoop.
Yeah, that's pretty good now, I think.
Okay, it's better. Okay, well, of course, this is dedicated to Marco, who offered us this chance to speak with all of you. And
I get to be a printer.
Yeah, so you're now a printer, of course, yes. So we're just initializing our entity state model. We're calling the graph versioner init procedure, and I'll explain this what we're putting in. Of course, we'll have the entity label, which is the printer, and this set of properties is those are the printer's properties. Of course, we are having a unique ID, the printer unique ID, its name, which is of course Mark, and an IP, because we're thinking that this is a printer of on our network. And then we'll creating, for this example, we're using a placeholder. Don't get mad with this status, which is a copy of the state additional label, just because we want to show you the name of the label on the node. So it's just a smart way to create this thing. The ready node that we are creating with our entity, it just doesn't have any properties, because it just states I'm ready for do something. So if we just launching this procedure, we will obtain the entity node that we have just created, and of course we'll have a current node, which as you can see there is the date, and the has state, which it has the same date as well, and the ready, which
I'm ready. I'm ready.
Mark is ready. Mark is ready. So we both have the ready label and the state one, yeah, which is of course created by the tool. Okay, then we want to update the state of our node. So we want to send something, some job to Mark, because we need to print something. So we're matching our printer with our specific ID, and then we're calling the update, which came up with the p variable that we use for the printer, and a series of properties. For example, the status, which, as I told before, is a placeholder for the state additional label, and a job ID, for example, a file URL, because maybe the printer is downloading a file stored somewhere else, and a template, which can be used for specifying which kind of file that the printer is going to print. Of course, the printing state. So if we just end up launching this, we're retrieving the state that we just created. which is connected to Mark, which is the printer. And here we go. We can see the whole model together. So just go through the relationships. The current and the has state relationship, we also have the same date as before, but the has state relationship has updated its end date, of course, with the current one. So basically, this state that this ready state is a past state. And of course, in the previous state, we can see we have the start date of that node. So basically, if we're navigating through the entity, the current, the printing, the previous, and the ready, we have all the dates and all the nodes that we need up. So basically, we can do some more things. For example, maybe Mark can handle this file.
Quick question. So Marco,
yes.
on this model, if you click on the Mark node again.
Yes.
So there's 3 pieces of information that these are like static. So these are not entity or state information, right? So the IP address, the name, and the UN. Those ones are like more fixed.
Yes, they're fixed. They won't change.
So if for example, we moved the printer, say, to a different network, that would require us to go and update the node rather than add a change. Of
course, we need to update the node. Yes, of course. States don't need that information because you can find that just relating them with its entity. So yeah, but it came up with the entity.
Actually, this is our way to think such example. If you think that that printer is going to change a lot the network address, you can place the IP property into the state node, and you will also use it as a.
You're not forced to put any property on any of those nodes. So cool. you can create a model just by using different labels, and this can work as well. So basically, we are simulating an error because something went wrong with the job that we just inserted on our printer, and as you can see, the status now is different because it's an error state. We just added a new property, which is the context. And of course, this is reporting what was the error. Cannot apply the given template to the given file. As you can see, we're trying to print a poster in a postcard template, which is wrong for our printer. So we can run again this query. And as you can see, we have the full model. Everything is connected together. So basically, it just added another node with a different label, which is the error one. So maybe the operator that is monitoring the printer is just saying, why is not printing anything? So it will use just a different procedure that we created for that. So what's going wrong? I want to know if any error has occurred. So I'm using the get by label procedure, which it will return every state node of a given entity that has that specific label, which is error. So this will return just an error. So the operator can see, oh, maybe an error has occurred. I just go through the error, and the context is just talking to me and say I cannot apply the given template to the given file.
Does that one show you all the errors, or would it just show
all the errors? Yes, but we are just in our future development, we want just to give the last one, for example, for a given entity, which can be really useful if you want to have just the last bad thing that happened or the good thing that happened on our state model.
Yeah.
But it will be a future development I hope in some months.
But I mean, I suppose at the moment, if you wanted to achieve that, you could just do some cipher post-processing after the procedure.
Yes. You can do that as well. You can mix the procedure result with another cipher query. So it's just something that you want to give out of the box. So, for example, I just need to know when the printer was good. So I'll do the same with the ready label. And I will obtain my node that this one has got the ID, which is 333, okay? And I will use it later. Because, for example, now I want to roll back to that state because that way our printer was working fine. So I will replace this with our ID. Okay. Okay, then, so I'm calling the rollback to. So I'm rollbacking to a specific state on our model. So let's go back with this. Okay, so for example, now I'm on error and I want to roll back to the ready node. So by calling this, okay, I'll end up with the whole connected thing. It is starting to become a little more connected. So, okay, as you can see, now the ready node is connected with the past ready node because this is the exact copy of the previous ready node, as we told you before. So basically now, if, for example, I want to roll back again, and the previous one was our rollback node, this relationship helps me to do a bridge between them. So I will go through this, and take the previous one. Of course, there is no previous node, but this can prevent the infinite loop between the last two nodes. So of course, we're ready again. We want to put a correct work together. So we replaced the correct template. So we're now printing a poster, for example, and we can run it again. Now the printer is actually printing. Let's connect all those now together. Okay, printing, and printing. Here we are. Okay, and of course I can add more nodes. For example, I can get everything done. So everything has been printed correctly. I'm updating the status with the label printed. So as I can see now, the whole thing is everything connected and working fine as well. Let me switch those. This is the correct order. This one. This one. Okay. Everything connected in the right order as well. So as you can see, we're adding many relationships, but all those relationships are helping you to understand better how the model has been made, and to, of course, use it efficiently as well. So we'll have, as we told you before, a little surprise, which is not a surprise at all, but we've done an upgrade to that. We created another module for our core versioner.
We started thinking it as a framework including utilities for other kind of situations, and we came up which is the main challenge for a graph to challenge against an SQL database, a relational database, because they're very wide used. And the challenge was firstly how can you see the structure of the SQL database, the relational database, in a graph way? So I can search, for example, for a table, for a specific column in a table, looking for the relationships of the table, and like so. Of course, you can write some not that nice queries on your SQL console and see the results. But using Cypher and graphs, it would be really easier. And after some months of thinking of it, we developed the Neo4j Versioner SQL, which imports the SQL database structure, your SQL database structures, in a graph. Only the structure, not the data. I want to state this out because it's a common question. Okay, so it again is a collection of procedures. It's strongly dependent on the core, Neo4j Versioner Core. That's the one we were talking before. And it's helping you on navigating your data. And in the future, probably it's going to help you even in modeling your data. Like you can create data as a graph and store it inside your Neo4j, inside, sorry, your
Yes,
the relational
as
database.
Alberto was saying, we want to do Cypher queries that will update your relational schema.
Yeah.
For example, directly from the browser.
Yeah. So here we are. So we have some bit different labels, but the concepts are the same. You can think at the database as an entity. It's an entity with its states, which are the structure of the database through the time. So, for example, you import your database structure today, and after 3 releases, you're going to import it again. It's not losing the previous data. It's just updating it, creating new states, and you can change the structure dynamically. Of course, we're recursively using the core entity state model. So the database is an entity with its own states. Its own states are, for example, the schema present currently in the database. So every schema, in 5 minutes, we're going to see even an example of it. But now I want just to state out the concepts. So we have the schemas, which are connected to the current database state. And of course, every schema has its own table. And now the interesting part comes, because for tables, it's easier to understand. The table structure, like columns and relationships and so on, you can see it as a state itself. So every state of the table represents the columns and the relationships pointing to other tables. Actually, it's not tables. The relationships will point out to the state of the tables,
which contains as a properties all the information about columns.
Yeah, but we'll explain it clearly with an image. And then what else to say? Okay, for every column we store just the type and some more information we see later. And a table, but even the schema in the database has the ID and the name, which is the name you give to the schema. Now, if you're changing the schema name or the table name, it will create a new entity. But if it's going to be a problem, we're going to work on it. But as a concept, it's going to create a new one. So what about relationships? Yeah, as I was talking before, connection between table states are relationships, which is the foreign keys, the SQL foreign keys. Okay, what else to say? Okay, here there are 3 examples of structure. There's a database having its state connected with a relation called a schema to a schema. The schema itself has its own state, which is connected with the relationships has table to a table, and the table itself is connected to other tables between the relation. Every relation, as you can see, has some properties helping you to understand which columns we are targeting in the specific tables, like destination column, source column, and even the constraint. If you find some problems somewhere pointing out the constraint name, you can search it on your graph imported database, and you find that relation, which are the tables that are connected between that relation, and so on. And this is the structure I was talking about. So the green node is the database. It's connected to the state, which is the current state. Of course, if you have previous versions, there are going to be much more has-state relationships between the database and its state. So you can also navigate the structure like the 3-month cycle structure. And in the future, you'll be able also to roll back database structure to a past version. So you can choose only the changes to apply to the DB. You do not have to apply all the changes as a bulk operation. You can just change and roll back 2 columns from a table without having to change also the other changes that can be stored in that change.
So as you can see, we are recursively applying the previous model that has been explained for the core. for example, the database has its own model, the schema has its own model, and the table has its own model as well.
Yeah.
As we explained before.
That's why we're strongly dependent from the Neo4j Versioner Core, because it's needed for versioning the versions and manage the difference between the past and the future versions. So this is the situation, and we call about the available procedure right now are only 2. Sorry for that, but we're working on it, and it's a hard work. Actually, there's the init version, the init versioner SQL, which is starts everything, imports everything from the SQL database. All you have to give to it is the connection to your database and the name of the database you want to import, and it's going to import everything into your Neo4j graph. And also, we're working on it. It's not a fully developed feature. That's why we released the .1, if I remember well. Yeah,
yes,
.1 version.
It's an early release.
The reload is just reloading the version. So given the current structure, which is the one already imported in your Neo4j database, by using reload, you're loading again, so writing new state of your database. So for example, if you're adding a table, it will create a new state on the schema with the new table, and add the table itself on the database with its relationships and so on. Of course, more than coming, because we're going to import the structure, but also write into the database. So we will add new procedures allowing you to directly write the changes you mark in some way on
or
the
maybe
database.
If you need to,
just
using some difference between the states, we want to generate a SQL code as well. So if you want, you can run it yourself.
Yeah.
Cool. So I guess we're getting pretty close to the hour. Have you got? Is there another demo?
Yes, but it's
yeah,
quick,
it's quick.
just
It's
because
quick.
we're importing
showcase the working of it. Let me search the decider here.
Okay, while you're setting that up, I'll just say to everyone, if you've got to drop off now, if you liked the presentation, don't forget to like it on YouTube so that more people can see it. And I guess while you're setting that up as well, we've got another question,
Yes,
which
great.
is how would you be able to use? You mentioned that there was a tool that would allow you to compare versions and show the difference between them. How would you use that on, for example, on the printer example?
Well, for example, if I want to use it on the printer, I can just search through our model and find, for example, a printed state. So something that went right, that will share with my current errored state, for example, as it came up with an error, which has, for example, the same template. So maybe I can say, okay, I've created a postcard, and it has been printed. So why this postcard didn't work? For example, I couldn't retrieve that state because I was creating a poster. So I can get a difference between them, and the diff procedure will show me that, of course, the template that I was trying to print didn't work. So this is an easy example that just came to mind at the moment. So, but for in this example of the SQL, of course, we can compare 2 different tables for the same table in 2 different states. Sorry, and we came up with the differences. The differences will generate in the next release SQL code that can lead me to switch between states on my current relational database.
Yeah, but I think that the printer's example is quite difficult to understand on such feature. It's much more easy to understand on the cart example.
Maybe on the cart, yes, of course.
Because you have a cart and you want to know what has changed from a specific cart to another one. And that procedure is showing you all the differences. So you see it's been added this property, it's been removed the other one. And if you see properties as items, it's easy to understand how it works.
So
yeah,
yes, tell us, Mark.
Yeah, no, yeah, you can continue with the demo. There's a slight delay from what people ask the questions, so I guess that they'll let us know if that was the answer was sufficient. In a second.
Okay, for example, we're showing a database. Yes.
Yeah, here we are. We will attempt to import a SQL database using our tool, and actually that database has 20 schemas, 322 and 12 tables, sorry, and 398 relationships. So it's not that big, but quite a big database, relational database.
Big enough.
Yeah, it's a demo database used by Microsoft, available online. And actually, while calling our procedure, yeah, just as you see, it already imported it. And we have the adventure, which is the database name. And if we navigate it, we see, can you navigate it?
Okay.
We see that the current state of the database has a relationship to all the schemas. So that could be the answer to the guy asking at the beginning if we're managing a relationship connected to the state and so on. Yeah, the core is not managing that, but you can easily do so because, as you can see here, we're doing it and it's working. So that's a way. We're thinking of a way to include the relationship in the states because probably it's going to be needed.
So as you can see, basically, every table state is connected with the other table state because there are foreign keys between them, and I think it's pretty self-explanatory.
Yeah, it's quite easy to see. Actually, I tried a query, an interesting query like. 100. We need to limit it because there are going to be too many of them. But now there are no relationships here.
No,
so.
because I'm not showing them. I cannot use up now. Okay, try to run it again.
Yeah.
Okay.
Yeah, that's it.
This is better.
Go to full screen. Go to full screen.
Full
And
screen.
zoom out.
Yeah. Your browser can't be happy with you.
Okay, so this is
that gives you an idea of what we're importing.
This is just a portion of that, because if you want to load everything, of course, the browser doesn't support that. We need maybe to use something better like Gephi or some other tools, for example.
Cool.
Okay.
Okay, so basically we've done.
Slides,
so we can just say what's next. So we want to create new releases about both the tool, the core and the SQL. As we just told you before, we have some feature in mind, but of course, if people just need any feature, they can propose it, or just since it's an open source project, they can just pull request it, or we can talk about that. We're open to that.
Yeah.
And of course, we will publish some projects on GitHub with our milestone that we want to reach. And maybe we'll, if time is enough, we'll create more modules like the SQL one.
Yeah.
So just stay tuned for any news.
Cool. Cool. You've got some. Thanks for the answers to your previous questions.
Oh, great!
That's cool.
Great.
It's a pleasure.
So yeah, I don't know if there are going to be any more questions, but otherwise, thanks for coming to present. This is really cool, and I guess we can put a link. Oh, you got a link. There we go. So you got a link.
Yeah.
We got also the link.
Where people can download it and play with it, and then they can obviously get in contact with you on Twitter, or I suppose through the page.
Yeah, so through the page.
Yeah,
of course.
We're always there.
Thank you to Mark for the chance.
Yeah.
Cool. All right. Well, thank you everyone for. There's a couple more questions, but we can answer them on Slack. Otherwise,
yes, of course we can
hold everyone back. So Neo4j Meetup wise, we're not doing one next week, but we'll do 2 the week after. So we're going to do one on the Game of Thrones. So we're doing a competition in August. So we've got to get that meetup in before Game of Thrones actually finishes season 7, and then we'll be doing one on the Thursday. So 2 weeks time. On Neo4j and GraphQL. So if you're interested in either of those, go to the meetup page and register there. Otherwise, thank you, Marco, Alberto, and
thank you too, Marco.
Thank you everyone for joining. Thank you.
Thank you everyone for joining.
Bye.
Bye.